let's dive right into this explainer. And, the best way to kick this off is actually with a pretty simple cooking analogy. Think about making a really complex meal. Having a giant pile of groceries sitting on your kitchen counter? Yeah, that is definitely not the same thing as having all those ingredients washed, chopped, and actually ready to cook. It's exactly the same in the machine learning world. Just like in your kitchen, raw data is completely, utterly useless until it's been properly prepared. I mean, you could have the highest quality ingredients on the planet, but if you toss a whole, unpeeled onion into a frying pan, you're not getting a gourmet meal. This preparation phase is absolutely vital.
So, if you caught part 1 of our explainer series, you know we've already acquired our data. We gathered our raw materials. That means we're ready to move straight into the critical second stage, data preprocessing. This is literally everything that happens to your data before a machine learning model ever even gets to see it.
Which brings us to section 1, what it actually is. And look who's here. Techie from AI Tech Hub is popping in to help us set the stage.
Essentially, data preprocessing is the concrete set of steps where we take raw, messy, totally chaotic real-world data and transform it into something a model can genuinely learn from. It's the bridge between human chaos and machine logic. Because let's be real, raw data almost never arrives ready to use. It usually looks like a terrifying, disorganized spreadsheet, and our job is to turn that into a mathematically clean structure.
Out in the real world, your data is just going to be riddled with issues. We are talking massive gaps with missing values, completely inconsistent formatting across the board, duplicate entries that totally throw off your counts, and weird text categories. A mathematical model simply cannot process those things on its own. Because remember, algorithms do math. They don't read messy spreadsheets.
And this brings us right back to a core concept, the classic broken machine metaphor. Unprocessed data fed into an algorithm guarantees garbage results. It's that simple. A model is only as good as what it actually learns from. You feed it garbage, it's going to learn to produce garbage. Pre-processing is the magic step where your data actually becomes usable.
All right, let's keep the momentum going with section 2, the main steps.
So how do we actually fix this giant mess? Well, we're going to rapidly break down the 4 sequential steps that almost all pre-processing pipelines follow. This way, you can see exactly how the cleanup happens in the real world. These aren't just high-level theories. These are the actual practical stages your data has to survive to become model-ready.
First up is cleaning, which is, well, exactly what it sounds like. You're grabbing a metaphorical broom and sweeping away the broken data points. This is where you have to make the tough calls. Do you try to estimate a missing value with a reasonable guess, or do you just scrub that incomplete record entirely?
Sweeping away these initial baseline errors is totally non-negotiable. If you want an accurate model, you have to strip out the duplicate records that skew your numbers and fix those blatantly wrong values that would otherwise send your model down a totally wrong path. Next up is transformation. Now, what's really fascinating here is how this step levels the playing field for all your variables. Machine learning models, they take everything super literally. So if you don't transform your data, the underlying math gets severely, dangerously distorted.
Think about it like this. Without scaling, a feature measured in the thousands will quietly and unfairly dominate a metric that's measured in single digits. The algorithm just sees a huge number and automatically assumes, oh, this must be vastly more important just because it's physically larger. Transformation normalizes all these different size metrics so they actually share the exact same scale.
Transformation also covers a neat process called encoding. You know how algorithms only speak math, right? Well, encoding translates words and categories, say a color or a country name, into the pure raw numbers a machine learning model actually demands.
Moving on to step 3, feature engineering. Honestly, this is probably my favorite part. It's basically the art of taking your raw puzzle pieces and combining them into a much, much smarter shape. You aren't gathering new data here. You're just maximizing the potential of what you already have sitting in front of you.
The crucial takeaway here is that you are actively building stronger, much more obvious patterns for your model to detect. You might combine 2 existing columns into a brand new signal that captures a trend way more directly than the raw data ever could have done on its own. And finally, we have splitting. This step is here to ensure you aren't just letting your model memorize the answers it's already seen. Think about it. If you test a model on the exact same data it used to learn, of course it's going to score 100%. It's literally like handing a student the answer key before they take the final exam. To prevent that kind of fake success, you slice your dataset up. By dividing the data into training, validation, and test sets,
You are guaranteeing your model gets tested against brand new realities. You're setting aside real, unseen data just to verify if the model actually learned the underlying patterns or if it just memorized the training set.
So there you have it. Those 4 concrete steps: cleaning, transformation, feature engineering, and splitting. And they are almost always executed in exactly this chronological order. Each step absolutely relies on the success of the one right before it to build a rock-solid foundation. Which brings us to our final section, the stakes, and why all of this actually matters.
Here's the thing. Skipping or rushing through the stage, it doesn't just make your data a bit messy, it breaks things silently in ways that are genuinely a nightmare to diagnose later on. A model trained on inconsistent scales or unhandled missing values will often look like it's working perfectly. It's going to spit out predictions, but underneath, it is fundamentally, dangerously unreliable. Model-ready data is literally the only way to ensure your AI's logic is built on a solid foundation. Skip this, and even the best algorithm in the world is just playing in the mud.
And that brilliantly wraps up step 2 of our life cycle. We've successfully taken raw chaos and turned it into something a model can genuinely learn from. Our data is acquired, it's washed, it's chopped, and it's finally ready for the pan.
By the way, if you're working on your own AI project right now, whether it's for your business or just for fun, and you want a hand navigating this exact life cycle, our mascot Techie is back on screen to remind you to reach out. You can easily get in touch with the team directly at info@aitechhub.ca.
Also, make sure you subscribe and comment the word Lifecycle down below if you want us to bring you part 3, where we're going to take all this beautifully pre-processed data and finally dive into the modeling phase.
Until next time, I want to leave you with one final thought. When an AI fails tomorrow, and it will, was the math actually wrong, or did someone simply feed it garbage? Thanks for joining me on this explainer, and I will catch you in part 3.